In this example, we are asked to find the following roots. Recall that by definition, the square root of a -1 equals I. So in this very first example, I'm going to actually show you the expanded way to compute the root, and then on the other ones, I'll just use a shortcut. So on this first root, I will actually rewrite it as -1 times 9 with the square root over the top. And then I would split it as square root of -1 times square root of 9. Doing this, by definition, square root of -1 is I, and then the square root of 9 would be 3. And so this particular example, the answer would be I times 3. Generally, we write the constant first, so it would be 3I as our final example. Coming over to the negative square root of -23, we do have two negative signs, however one is on the outside and one is underneath, so they cannot combine to give you a positive value. What I would do here is think of the negative on the outside as an understood -1. Think about the inside as -1 times 23. We know that the square root of -1 is I, so that would come out. And then 23 is a prime number, it doesn't factor further, so we can't take the square root of 23. It would have to stay behind under the root. And so this one would simplify to -I square roots of 23. Generally, we think about if we have a square root and there's a negative value underneath, then we know we're going to have an I in the answer. Now in the last one we have square root of -96. The first thing I'd like to do is take the 96 and see if we can factor it. It actually does factor. And what we want to do in factoring is see if it's divisible by a perfect square. So numbers like 4 and 16 and 9 and 25 are perfect squares. If we take 96 and we divide it by 16, it turns out that 16 into 96 goes 6 times. So we can factor that 96. And so here what I would do, we could factor the 6 further. It's not a perfect square. We could factor it as 2 and 3. Both of those numbers are prime, and so it's actually not necessary to factor that 6 further, since both the 2 and 3 are prime and they don't contain any perfect squares. We can actually back up a step. And so on this one, what we will do is basically do this in 3 steps. We have a negative under a square root. That would come out as I. We would then take the square root of 16. That is 4. We cannot take the square root of 6, and so that would have to stay behind under the root. And so on this one, it would be 4I root of 6 as our final answer.